why would I use make shared over just newing an object and passing it into the constructor?
Um, um, so yes, I've applied to a few. I'm a little bit intimidated about the big ones, so I applied to a few smaller ones. I'm in Europe, by the way, and I'm applying to Amsterdam
Okay.
because that is where the hub seems to be. And I think I have a positive response. So just wanted to see where the holes in my knowledge are, what I can do to improve.
Okay, so you have a C plus, you're a C++ developer,
Yes,
and how many years of experience do you have?
2 to 3 years of experience.
Okay, what classes did you take in school? Because I want to know kind of what's fair game to ask you.
So I have a bachelor's and master's in computer science. I took like the core courses, operating systems, distributed systems, algorithms, some machine learning stuff. Because
Networking?
of yes, networking as well.
Okay. A lot of these companies, especially the larger they get, in my opinion, the more they care about your C++ fundamentals, so I think I want to start there.
Okay.
Cool. Let's start with some questions that I haven't asked. What's a trailing return type? Let's start easy.
A trailing return type.
Yeah.
I'm not sure. Is it something to do with the C++ syntax?
Yeah. It's an alternative way to specify a return type.
All right, with the arrow, basically the pointer notation. Or
Right.
what's it called? The arrow and the sign, the greater than sign.
Right. Now this is where we go from basic to intermediate.
Mm-hmm.
Where would that be useful? Where is that better than specifying the return type in the standard way without using the auto keyword? Because there's two ways. You can specify type, function name, parameter list, CV qualifiers.
Mm-hmm.
Or you can specify auto, function name, parameter list, CV qualifiers, trailing return type. Where is the latter preferable to the former?
I have seen it mostly used with lambdas.
Okay, that's one, but I'm referring to like a method, not a lambda. I know a lambda is an anonymous method, but I'm talking about like, let's just say a class. Where would it might be used? Where would I prefer to use that on a class method?
I don't know. I have no idea.
Okay, that's fine. I
Where it
want
would
you
be
to admit.
better.
I'd want you to admit where you don't know, and I don't want you to guess. I
Mm-hmm.
want you to guess if you have a 80 to 90% confidence, not a 0% confidence. So why do I ask this? And some people might think that, oh, this seems like some weird contrived question. Well, to me, it's how much exposure do you have with nested classes? Because this is where like for example, writing code that might require nested classes. What people can do is they can write a class in a class, right? And sometimes the
Yes.
inner class might be like a plain old data type that might be returned from the outer class in a method of the outer class. And oftentimes, if I want to access the inner class from the outer class, the type name, the type, what operator do I need to use? So I do class A, and then I do operator, and I do class B.
Um, what is the operator called? The two
So
dots, I think.
yeah, the two dots, what's that called?
Um, it's called the. It's blanking right now.
That's okay. Scope resolution operator.
Yes,
Okay?
yes.
So oftentimes if you want to return the inner class and you want to have the return type as the part of the left side of the function signature, not as the trailing return type, you need to do type A, scope resolution operator type B. With a trailing return type, you can do auto, and then you can do the method name, and then you can do trailing return type, just type B. Why is that the case? Well, because by the time you get to the trailing return type, you're already in class scope because you're you're defining the method on the class. So you can effectively save characters to type. But I just, because some people want, because I want to find like, this is a more intermediate question because I want to see how much you've used these sorts of things and how much you've thought about them. Okay, let's talk a bit about C++ 17. What's your favorite addition in C++ 17?
So I think what was introduced there and what I used is I think what they call structured bindings.
Okay.
So where it comes handy is let's say you have a map.
And you
And
iterate over the keys and the values, yeah.
exactly, yes.
Now, that's the easy answer. Now,
Yeah.
what they might ask you is not tell me your favorite feature, but tell me 3 features. So give me one more, because that's an easy one.
I think optionals were also introduced in 17. Still
Yeah.
optional.
Okay. Yeah, good one there. I like that one too. Okay, what's the type you get when you add 2 booleans? If I do auto,
Mm-hmm.
A equals true plus false. What is auto?
I want to say bool. It should be bool, but I have no idea really.
But yes, to see what does it mean to add 2 bools?
Um, I'm not sure what it means. So how plus is defined for 2 bools? It could
Yeah,
be an OR operation, or it could not be defined at all.
right. So it is defined, but effectively, if you put this into like CPP insights, you'll
Mm-hmm.
see there's actually a static cast to int.
Okay.
Right. So they're promoted to ints.
Okay.
Yeah. That was a bit. Some people get mad at me like, "Oh, this is C++ trivia." It's more kind of warming you up to see how much you've actually interacted with C++. Let me get to some more like common things you might see in C++. Do you know what the most vexing parse is in C++?
The most vexing parse. Um, yes, I have. I have heard of it. I have encountered it. Let me see if I can recall it.
Yeah.
Um,
And once again, nobody knows who you are, so if you don't feel embarrassed if you don't know, because I'd rather you not know here than not know in an interview.
no, I actually know this. It's something to do with declarations.
Mm-hmm.
I just can't recall it. It's something to do with declarations inside classes.
Not necessarily inside classes. Effectively, what C++ says is, the standard says, is anything that can be interpreted as a function call will be.
Yes,
And so
that
if you
is
have
correct.
something like int f brackets, and you forward declare a function signature, or you forward declare a method, that'll interpret that not as you are, that will interpret that as I have forward declared a method that returns int that's called f and takes in no parameters.
Mm-hmm.
That is not spawning an integer with a variable named f. How would I solve that though? How would I tell the compiler that no, this is not a function forward declaration. This is indeed an integer variable called f.
You could use brace initialization, for example.
That's right. That's right. So, okay. Um, have you heard of the static initialization order fiasco?
No.
Okay, that might be important because that's related to, this is not trivia anymore, this is like compilation. So this is the aspect of C++ and a lot of people don't know about and it's misunderstood. Effectively, when you declare a static global variable in a translation unit,
Mm-hmm.
the order in which these translation units are compiled will affect the actual values themselves because static variables in a translation unit are always initialized in their order of definition. So take a look at that because what that means is that static variables, depending on the order of compilation of translation units, they have a 50% chance of essentially like failing to be initialized correctly. So I'd write that down and I'd take a look at that a little later, the static initialization. It's best shown through a code example and I can't do that now. Let's talk about virtual because virtual shit's always that's in an interview.
Mm-hmm.
So let's start with the basics. This is like a question I might give a junior. What's the difference between function overloading and function overriding?
So overloading is where you have, let's say, a behavior defined in a function, and then you define No, let me start with overriding first. Overriding is where, let's say you have a function defined in a base class, and then you override that behavior in a subclass or a derived class.
Okay.
Overloading is with different signatures. So basically, depending on the signature, uh, it's decided which exact function gets called, although the name might be exactly the same.
Okay. Now let's talk. Okay, that's the basic question. Then I might ask, for example, like, what is a virtual method, and what costs might the program incur by adding a virtual method?
That's a good question. So there is a runtime cost involved
Okay.
with defining a virtual method, because if the method is called polymorphically, so
Via a pointer of the base class, sure, I get it.
yes, the pointer of the base class. So the runtime has to look up how this object was instantiated, and then based on that find out what overridden method to use. And
Sure.
this is done by way of a vtable inside.
Okay. And why is that expensive? So there's that runtime cost. Why is it?
Yes.
Why might that cost be expensive? As in,
Because
like,
of the lookup.
why is it costly to do that?
Because of the lookup to do the method call.
So the
Otherwise,
lookup is actually simple because it's just simple pointer, it's just arithmetic to find the index in the array of the function and retrieve that function. But there's something a step further that I'm looking for.
it could be because of caching, perhaps.
Okay, you're getting close, so what about it?
So you essentially, so since this function or this overridden function could be stored somewhere else in the memory, this function needs to be fetched in, and and then executed. And
Yes.
this might not be in the cache.
Yeah. Okay. Yeah, that's correct. I'll give you points there. We kind of talked about this, but I just want to be clear about it. What does adding even one virtual method do to the size of an object?
It increases it.
Okay, by how much?
Well, I would say at least by the size of one pointer.
And what's that pointer called?
The vtable.
Vtable pointer, not the vtable.
Yes. Yes, the
You
vtable pointer.
You have to be very clear there.
Yes.
So okay, where's the is the vtable? Why doesn't the vtable contribute to the size of a class?
I think the vtable is stored outside the class.
What does that mean? It's stored outside the class.
I'm not completely sure, but
Okay.
I'm guessing here now.
That's okay. So it's stored outside of it because it's a static object on the class. So it's a static table. It doesn't contribute to the size of any instance itself. It's not part of the class. Okay. This is going to be a bonus for you because this shows me just how much you're familiar with polymorphism and virtual methods and inheritance. Have you heard of what a covariant return type is, and can you explain what that is? It's actually kind of handy, but nobody really knows about it.
No, I haven't. A covariant return type.
Yeah. And I can explain it if you don't know.
Yes, please go ahead.
Okay, so let's say I have a virtual method that returns a pointer to the base class. Like let's say the base is A. Okay?
Mm-hmm.
Let's say I have a class that inherits from the class that has that virtual method, and I override it. I can actually return a narrower type. So I can actually return a pointer to B instead of a pointer to A. I can change the return type of the same method. So I can override a method and change its return type to a more narrower version. Why might that be useful? There's actually like a really clear example in the C++ daily interview book. Essentially, like let's say you have like a car factory, right? The base class is a car, and you might from car you might inherit SUV. So in the base class you return a car pointer, but in the SUV factory, not the car factory, in the SUV factory that inherits from the car factory, you can return an SUV pointer from that same method. You don't have to create a new method. Okay?
Okay.
Now,
That seems very handy.
yeah. Something that you also might get questions about is virtual inheritance. When would you use virtual inheritance?
Virtual inheritance. I'm not sure if I understand what you mean by virtual inheritance.
Okay. Have you heard of what the diamond inheritance problem is?
The diamond inheritance problem, yes.
What is it? Sorry, I should ask, do you know what it is, not have you heard it? Do you know what it is?
Yes, I do.
What is it?
So it's basically comes up in multiple inheritance.
Okay.
So let's say you have a class that inherits from two classes or inherits two classes. Or wait, is it the other way around?
No, you're on the right track. Let me kind of help you out here because I want to push things forward. So yeah, if you have a class that inherits from two classes and those two classes both inherit from the same base class, effectively each of those two classes in the middle have a copy of methods from the base class.
Yes.
And
yes.
when the class D that inherits from both B and C essentially take in those methods, they have now essentially duplicate from each one. Now you can access them with the scope resolution operator, say like B, class B dot whatever, or class C dot whatever, but effectively there's going to be an ambiguous function call if you don't use the scope resolution operator, because it's not going to know, do you want method A from class B or method A from class C? So what you need to use is virtual inheritance to deduplicate that ambiguity. Okay? So this is actually, people say this is C++ trivia. I actually got this question in an interview. So that's going to be important to know. And what is a weak pointer and when would you use it?
A weak pointer, I have actually never used it, but I think the usage there was to allow it to be used like shared pointers, but then you can also have non-owning references to this type.
Okay, I'll give you half points there. There was a word that I'm looking for. It fixes something that starts with a C.
Yeah, I don't know about that.
Okay, it's called cyclical references. So if two objects have a shared pointer that point to both of them, and they both go out of scope, it prevents a memory leak in that case. Let me now take it a step further. So this is still an intermediate question, and we're a little on shaky ground on the intermediate stuff, but I'm going to continue to probe. So you know how you can when I create a shared pointer, first of all, what does it take in the constructor?
A shared pointer could take an R-value reference, or it could take a unique pointer as well. I think it has many overloaded constructors.
What's the most fundamental thing that it needs to manage? Well, it takes in... There's something that a shared pointer takes in to manage. Let's say a shared pointer takes in nothing. What's the reference count? Let's start there.
It takes in nothing?
Yeah, I just do shared pointer int pointer, semicolon. What's the reference count in that pointer?
I think I'm not 100% sure. I'm guessing 1 because it has to construct the object that it owns, or that it calls the constructor of that object at least once.
No. The default constructor of shared pointer doesn't create anything.
Okay.
So if this was an interview, that would be a red flag.
Okay.
So that's the default constructor of shared pointer, but it has another constructor that manages an object. What does that constructor take in?
A reference to an object?
No, it takes in a something to an object. What do smart pointers manage?
Pointers or memory.
Right.
Mostly.
So what should the constructor of a shared pointer take in?
A pointer as well?
Yep.
Mm-hmm.
So it takes in a raw pointer.
Mm-hmm.
Now, this is where I actually wanted to ask the intermediate question.
Okay.
That's just one of the constructors, but in that constructor, there's really name me the two ways to seed a shared pointer with an unmanaged object. So we can either pass in a raw pointer, or what other ways can we create a shared pointer to an object?
There's the make shared function that the stand-up library provides.
That's right. Why would I use make shared over just newing an object and passing it into the constructor?